Hi student, today's class we will be discussing about acid, base and salt. Here is the most common acid, sulfuric acid, hydrochloric acid and nitric acid as well. Especially concentrated acids are really corrosive. We need eye protections and gloves as well. In short, I would say acid is a substance which gives hydrogen ions in aqueous solutions. Here is the examples you could find out the common acids. Let me ask you questions. What makes an acid acidic? All acid forms hydrogen ions when we dissolve them in water actually. This makes the solution acidic. You could see hydrochloric acid, when it is being dissolved in water, it's going to form actually hydrogen ions and chlorine ions. And basically you can find it how hydrochloric ion is being dissolved in waters and how it is forming hydrogen ions and chlorine ions. Now let us talk about base. And a base is a substance which can neutralize an acid. Some typical bases like metal oxide, metal hydroxide, and some bases are soluble in water, so these soluble bases have a special name, is called like alkali. And like acid alkalis, especially concentrated one, are really corrosive. For examples, you can find here sodium hydroxide, potassium hydroxide and calcium hydroxide as well. When alkalis dissolve in water, it produces hydroxide ions, so that solution we call it alkaline solution. So here you can find that examples what makes an alkalines. So when sodium hydroxide dissolve in water, it's going to form sodium plus ion, I mean sodium ion and hydroxide ion. And basically you have to remember alkalis is caused by hydroxide ion. One of the cleanest examples of this neutralization reaction you can find in this. So we stated that all acids are acid because they produces hydrogen ions, and all alkalis are alkaline because they produces hydroxide ion. You can find it hydrogen ion and hydroxide ion react together, hence the result is water. And basically water is neutral in state with pH value 7. And important of this reaction, student, especially in titrations. Now come to pH scale. The pH scale basically is used to measure acidic and basic nature of the solution. And if you look at the pH scale, the range of the scale could be 0 to 14, and exactly 7 could be the neutral, what we considered water is neutral in state, and above 7 towards 14 actually basic, and below 7 is actually acidic. And the lower of pH more acidic in the solution, in which the higher concentration of hydrogen ion in aqueous solution. The higher of pH, the more basic in solution, in which a higher concentration of hydroxide ion in the solution. Here you can see the diagrams in the form of pie chart. It is given the strength of the acid and base, so easily you can find out the strength of the pH value of solution. And now come to the simplest definition of the acid and base. If I define about the acid and base, so I would say in very short, acid is a substance which can generate hydrogen ions in aqueous. Base is a substance which can generate hydroxide ion in aqueous solution. Bases are generally metal oxide and hydroxide also. Here is the pH indicator, like litmus paper and some other solution as well. Now if you talk about this two couple of paper, like a red litmus paper and blue litmus paper, pH is just simply just tell you that a solution is acidic or alkaline. Here if you take or if you use the red litmus paper and put it there in acid, no changes will be found, right? If you put it there in the alkali, then you can find the changes from red to blue color. Similar way, if you take the blue litmus paper and put it there in acidic medium, so you may find the changes from blue to red color. So we can say that acid changes the litmus paper red alkaline, turns litmus paper blue. And here is the methyl orange indicator as well. Basically this methyl orange indicator, if it is kept in acidic solution, it shows like red and orange colors. If it is kept in alkaline medium, it will show you yellow colors. Now come to neutralization. Here is neutralization reaction between acid and base. Basically, when acid react with base, it gives rise to salt and the water will be obtained as a byproduct. Here hydrogen ions, it comes from the acid, and hydroxide ion, it belongs to base, and then it forms water. Now if you talk about the acid reactions, here actually acid react with metal, it gives rise to salt and hydrogen gas. Here is the examples of acid, how it react with metals, and how could you find it the salt with the hydrogen gas. You can find it over here. Magnesium, when it react with hydrochloric acid, a strong acid, and gives rise to magnesium chloride in the form of salt and gives even hydrogen gas. In the second examples you can find, it is the reaction between metal oxide and sulfuric acid. I mean copper oxide, when it react with sulfuric acid, what compound could you find in the form of salt? You can find it, the copper sulfate is a salt and water will be released. In the similar way, if you look at the hydrochloric acid, how it is react with sodium carbonate, and then what would be the product you can find? Sodium chloride and water and carbon dioxide also you can find. Here is the reaction between hydrochloric acid and sodium carbonate. Hence the result will be sodium chloride and water. Of course, there is a production of carbon dioxide as well. Now let us move on to the base reactions. How the base reaction takes place. Basically this is also like acid base reactions and will form salt and water. In the first examples you could see the copper oxide and sulfuric acid react together and it forms copper sulfate water, right? Here is the another example of base reaction. And now let us move on to strong acid and base. Acid releases actually hydrogen ions in aqueous solution, and base releases hydroxide ion in the aqueous solution. A strong acid will have a high concentration of hydrogen ions, and a strong base will have a high concentration of hydroxide ions. Basically, if you like to define the definition of strong base and strong acid, then you could do it for let's say strong acid is a substance which can dissociate completely, I mean broken down completely into ions in a aqueous medium, is called strong acid. Strong base is a substance which can dissociate, I mean broken down completely into ions in a aqueous medium, is known as strong base. So here is the couple of examples you could see. Hydrochloric acid is a strong acid, sodium hydroxide is a strong base. Strong base, how it can dissociate, I mean how it can be broken down into two different ions. Here I could give examples. For let's say if you have 100 molecules of hydrochloric acid, you will expect all of them to break down to form hydrogen ions and chlorine ions. So this is called like complete dissociation or completely broken down into two different ions. So we called it strong acids. If you talk about strong base, sodium hydroxide, the same examples I could give you. Let's say if you have 100 molecules of sodium hydroxide, you will expect all of them to break down into two different ions, sodium ions and hydroxide ions. Here you will get lot of hydroxide ion. So here also you can find it, there is a complete dissociation. Now let's move on to weak acid and weak base. A weak acid and base actually generally they release small amount of hydrogen ions of hydroxide ion, because the molecules are partially ionized in a aqueous solution. Here is two different examples of weak acid and weak base. One example you could say ethanoic acid. Here is how ethanoic acid is being converted into two different ions, I mean dissociate into two different ions. Let's say if here is 100 molecules of ethanoic acid is reacted, then only 2 to 3 will dissociate, I mean they will break down into ions. So here we will find less concentration of hydrogen ion. Similar way, if you talk about ammonia, here ammonia when it reacts with water, it gives rise to hydroxide ion and ammonium ions. So here also ammonia will dissociate partially. So now come to oxide. Most metal oxides are actually basic. Soluble bases are called alkali and they turn litmus paper blue. Insoluble bases will not affect the litmus paper actually. So non-metal oxides are usually neutral or acidic. Natural oxides such as water, nitrogen oxide and carbon monoxide, they do not react with acid or base actually. And acid oxide, acidic oxide, like sulfur dioxide and sulfur trioxide, carbon dioxide and other oxide like phosphorus oxide also, they will turn the litmus paper red and neutralize the bases. Here is amphoteric oxide react either a base or acid to form salt and water. This means oxide have a property of both like acid and base. So now let us have examples of amphoteric oxides, how they behave as a acid and then behave as a base. You could see the zinc oxide when it react with sodium hydroxide, it gives rise to sodium zincate or Na2 ZnO2 plus water. Okay, so sodium oxide here play as a acid and sodium hydroxide is a base. It is a acid base reaction, gives rise to salt and water. The similar way you could see zinc oxide here behave as a base, and here is nitric acid is there, acid and base react with and a compound is formed. So this is amphoteric oxide. Here is the revised definition of acid and bases. According to Arrhenius' theory of acid and bases, he says that acid is a substance that releases hydrogen ions in a solution and base is a substance which releases hydroxide ion in the solution. We know ammonia base exhibit alkaline property but containing no hydroxide ion. How it possible? In this slide we will discuss about Bronsted-Lowry theories of acid and bases which fill the gap of the Arrhenius theory. We know acid pH value lower than 7, right? We can test the acid by using universal indicator or by the help of litmus paper as well, which turn orange red depending upon the strength of the acid. Blue litmus paper also turn red in presence of acid. For examples of acid you have here hydrochloric acid, right? When hydrochloric acid dissolve in water, it dissociate into hydrogen ions and chlorine ions. So here the water accept hydrogen ion to form which ion? Here actually water accept hydrogen ion to form hydronium ion, and this hydronium ion also known as oxonium ions. According to Bronsted-Lowry, acid-base theory says that acid is a substance which can donate proton, I mean proton donor. Example, you can take hydrochloric acid. Base is a proton acceptor, example water. We'll notice that the definition of Bronsted-Lowry acid-base theory is not a function of pH. In acid-base reaction, according to Bronsted-Lowry theory, involve the transfer of proton from one substance to another substance actually. So actually in introduction I mentioned that ammonia acts as a base even though it doesn't release hydroxide ion, in which stipulated in the Arrhenius theory. When ammonia dissolve in water, actually it accepts proton from the water. This reaction involves proton transformation, or you can say the proton will be transferred. This is example of water act as a Bronsted-Lowry acid because it releases proton. What it releases? Because it releases proton. And ammonia act as a Bronsted base because it accepts proton. According to Bronsted acid-base theory does not need to have pH greater than 7, or red litmus paper turns blue, or turns universal indicator solution blue or purple. Only the requirement is that it able to accept protons. You might have noticed water act as a base in first example, right? And water act as a acid in the second example. Substances that act as either an acid or base are called amphoteric. In conclusion, Bronsted-Lowry theories acid that releases hydrogen ions and base that accept protons. Therefore, the acid-base reaction, there is a transfer of proton only. Now the next slide will be the formation of salt. So how to make salt? Basically, a salt is made when the hydrogen ion in an acid are replaced by a metal ion or a ammonium ions. Student, we have a huge uh, kind of salt, like complex salt and compound salt, and now normal, I mean common salt. So basically, common salt or table salt in the form of sodium chloride, right? In fact, the salt has two parts. The first part will be metal ion or ammonium ion, and second part, which acid hydrogen ion will be replaced by in. For example, sodium chloride is produced by a replacing hydrogen ion with sodium plus ion. So here you can see in the example, all the chlorides start with hydrochloric acid. In this example, you can see magnesium sulfate here. So magnesium sulfate is replaced by hydrogen ions with magnesium. So the sulfate comes from the sulfuric acid. Here chloride comes from hydrochloric acid, and nitrate comes from the nitric acids here. So the acid derived in this sulfate actually sulfuric acid. Ammonium nitrate is actually important fertilizers. Over here you could see. Now take a look here from the hydrochloric acid. When it is being divided into two different ions, this hydrogen ions actually being replaced by the metal sodium. Similar way you could see in the magnesium sulfate from the acid sulfuric acid here, and this will be dissociated into two different ions, as we have two couple of hydrogen ions. So this two hydrogen ion is being replaced by a metal. Which metal is the magnesium metal? So it is magnesium sulfate, and then followed by the ammonium nitrate. So from the nitric acid, when the nitric acid dissociate into two different ions, here is the hydrogen ion is being replaced by ammonium ions. So this is the formation of making salt. And now let us discuss the making of soluble salt. Here is acid with metal. General equation you could see here, metal plus acid, and the result will be salt, and of course the hydrogen gas will be produced. Here is the example, zinc react with sulfuric acid gives rise to zinc sulfate and hydrogen gas. So this is basically as the metal react with sulfuric acid, it is a kind of exothermic reaction. So what is the working method? So basically the reactive metals, like if react with kind of strong acid, it is very dangerous. And if you react in fact high reactive metals like sodium or potassium, it's gonna be like a very exothermic reaction. Maximum heat energy will be produced. So how to prepare this soluble salt? The first step is to add the metal to acid until no more bubbling is seen. I mean bubbling into this fizzing. Then filter the remove unreactive metal, leaving the salt solution over there. And then third step, you have to heat the solution into the evaporating dish to remove some of the water from that, and then allow to cool from the crystals. And the first step, filter to remove the crystal and dry them, warm also, and leave the warm place for the water to evaporate it. Then you can prepare the soluble crystal or soluble salt. Now let us have a look here. the acid with the insoluble bases. General equation you could see over here: metal oxide react with acid and it's gonna be formed like salt and water. Here is the example: copper oxide and react to sulfuric acid gives copper sulfate and water. How you can prepare it? The working method will be all the metal usually making salt of unreacting metals like copper and lead. The methodology, the what how to make it this. So the first method is add some metal oxide to acid until no more will dissolve. All the acid has to reacted while warming the acid. The filter, the remove unreacting metal oxide and leaving the salt solution over there, and then heat the solution in the evaporating dish similarly to remove the some of the water, and then allow to cool, and then it will become like a crystals and you have to filter it. Then come here is you can see acid with insoluble metal carbonate. Here is the general equation. You can find metal carbonate plus acid gives rise to salt and water, and carbon dioxide is being produced here. And magnesium carbonate plus hydrochloric acid gives rise to magnesium chloride and water and carbon dioxide. How you can prepare this insoluble metal carbonate? Here is the working method. All the insoluble metal carbonate actually useful for the making salt and unreacting metals like the method to prepare insoluble metal carbonate. The first step is to add the metal carbonate to acid until no more fizzing. Acid has to react it. In the second step you have to filter to remove unreactive metal carbonate. In the third step, heat the solution in a evaporating dish to remove some of the water and allow to cool it. The fourth step you have to filter to remove the crystals. Similar way in the fourth point, how to make a soluble metal hydroxide. General equation you can find: sodium hydroxide react with hydrochloric acid and the result will be sodium chloride and water will be produced. The working methodology: all the alkalis useful for the salt of reactive metals such as sodium or potassium, and to make ammonium salt. So basically this soluble metal hydroxide we can prepare. The methodology will be: first actually you need to add the acid progressively to the alkali or a soluble metal carbonate, testing the pH periodically using a pH probes or removing the drop, and testing with a universal indicator actually. And then the second step you have to stop when the pH comes to 7. It will be neutral. And in the third step you have to heat the solution in a evaporating dish to remove some of the water, and then allow to cool to form a crystal. In the first step you have to filter to remove the crystals and you have to dry it. Then after that water will be get evaporated. And then now come to the ammonium salt. Here actually ammonia is a molecules NH3 and ammonium is an ions from ammonia only. This is NH4 ions. When ammonia dissolve in water it form ammonium, and hydroxide solution like ammonia when it react with water and gives rise to ammonium hydroxide. Here is the equations you can see. Ammonium nitrate and ammonium sulfate are important fertilizers. It is actually useful in our day-to-day life also. And making insoluble salt by a pretty this is pretty interesting to know. This insoluble salt we can prepare by a precipitation reactions. Here basically we can say a precipitation reaction. It is a solid form in a solution when product of reaction is insoluble actually. We cannot use the method we used before because the insoluble product would end up mixed with this insoluble metals. The metal oxide or metal carbonate reactant actually it is difficult to separate two solid. So instead, the method to make insoluble salt, the first is two solutions are mixed and then precipitate forms. In the second step, precipitate is removed from remaining solution by filtration. In the third step, solid residue has to wash with the distilled water and then let it. Now add acidic solution and alkaline solution. As a result, we'll be getting salt and water will be released as a byproduct. So does it happen every time? I mean, will an acid and base always give a salt and water? Yes, it will be always like that. When acid combined with base will give salt and water, what is the reaction called? Do you know? The reaction will be neutralization reaction. In this neutralization reaction, acid has to react with alkali and gives rise to salt. Here is the strength of acid and base. It brought to neutral point by intensity of acid and base. The best example of neutralization reaction is the formation of salt. I mean table salt, NaCl. If NaCl is formed by the reaction of hydrochloric acid and sodium hydroxide, when it is react together, the result will be sodium chloride and water will be produced. So here water will be produced as a byproduct. So this reaction is called neutralization reaction, and in this reaction the heat also will be released. Now you can find out how hydrochloric acid is reacted with sodium hydroxide, and the result is sodium chloride and water with heat will be produced. So it is also known as exothermic reaction. And acid base titration and how to calculate unknown concentration for acid and base given the balanced equations. We can react acid and base control way by adding acid to the alkalis and by the help of the indicators, and the neutralization is achieved. This is called titration process, and once indicator change the color in the specific volume of acid and alkali, you have made an endpoint and titration is complete. Let's have a example of this neutralization reaction given in the equation. Now 25 centimeter cube of sodium hydroxide solution into the conical flask and titrated with a standard solution of 0.1 mole per decimeter cube of hydrochloric acid by using suitable indicator, and then you have to take 25 centimeter of acid is required to neutralize as found in the titration. This is the end point for the titration. Now we can calculate the sodium hydroxide concentration is in mole per decimeter cubed. Use of the information given here, you can find out what is being given and then concentration how to be found. Use the information given in the table and we will get the answer, and this table will look like this. Here is the mole ratio of sodium hydroxide and hydrochloric acid. You can find it 1:1, and in order to find the concentrations you can use the triangle formula here. Okay, now here is the triangle formula in order to find the mole. First find the mole. Here is the information about the volume of sodium hydroxide is 0.025 decimeter cubed, and then hydrochloric volume also we have here 0.025 decimeter cubes. And now you could see the ratio of sodium hydroxide and hydrochloric acid 1:1. So same number of mole is being produced in both of case, sodium hydroxide and hydrochloric acid. Now by using this triangle formula you have to find the concentration of sodium hydroxide. Now how to find the concentration of sodium hydroxide? You know the formula. Now by using this triangle formula you can find the concentration of sodium hydroxide. Here is the formula. Concentration is equal to number of mole divided by volume. So it is being given